Welcome to my YouTube channel.
This is the Universal Data Boy, or you can call me the A+ Ambassador. Today I'll be solving stereo sheet 7 on simple harmonic motion coming all the way from Levy Mwanawasa Medical University. In case you have any queries, problems, or questions that you want me to solve, you can inbox the problem to this number. So we go right away into question 1, which says an object oscillates with simple harmonic motion along the x-axis. Its position varies with time according to the equation x is equal to 3 meters, the cosine of pi t plus pi over 6. So then where t is in seconds and the angles in the parentheses are in radians. So since we've been taught the angles are in radians, we'll do to change our calculator to radians. And then also one other thing is we have to liken this equation to the parent equation that we have on simple harmonic motion, because simple harmonic motion is sinusoidal motion, so it follows the sine or the cosine graph. So the cosine graph comes like this. It goes that way. Yeah, so this is the one that we are being given, and then we are being taught all these variables, and we know it's starting from there because it's cosine. So right away we can liken this equation to our parent equation, which is x is equal to a cos wt in parentheses plus the first difference. Sometimes some people use x naught instead of a, but we all know it's the amplitude at the end of the day. We are being taught in a to determine the amplitude, so we have a, we are determining the amplitude of the motion. So now the amplitude is simply the figure that's before the cos. So if we liken these two, we are going to find that the amplitude is just simply 3.00 meters. And then we are also being taught to determine the frequency. So we have determined the amplitude. Now we are going to the frequency. For the frequency, we've not been given directly, but then we can, when we liken these two equations, we are going to find that Wt is the same as pi t. So since t is equal to t, then W is equal to pi radian. So definitely we know that W is the angular frequency and it's equal to pi, because when we equate Wt being equal to pi t, which is what is there and what is also there, when we cancel out the t's, we are going to have our W being equal to pi radians, or just pi rads. And then from there we can write this in the terms of frequency, where we have the angular frequency being equal to 2 pi the frequency. So here, since 2 and pi are constants, we can definitely find the frequency. So we're going to make f subject of the formula by multiplying both sides by 1 over 2 pi. Pi can cancel with this one. Then we're going to have the frequency being equal to W over 2 pi. Now we know our angular frequency is pi rads. So when we substitute it into the equation, we are going to have pi over 2 pi being our frequency, and then pi and pi will can cancel out. So we are going to have our frequency to be equal to 1/2, which is the same as 0.5, and then the SI units are hertz. Then we are being told also to find the period of the motion. So we are being told to find the period of the motion. So now we know that period t is equal to 1/f. It's just the inverse of f. So our t is being equal to 1/0.5. So then our t will be simply 0.5 is just 2. You can counter check with our calculator. 1 divided by 0.5, yeah, it's 2, and then the SI unit is seconds. So then we are done with the first part of the question A. So then we go to B. So part B says calculate the velocity and the acceleration at any time t. So now here in this question, we are being told to find the symbolic answer and not a value. So we are being told to find a symbolic answer, a formula, such that when we plug in t, it will give us the velocity, and then when we plug in t also, it will give us the acceleration. So here we can summon calculus. When we differentiate our equation, that is the first one for the displacement x. When we say dx over dt, it will give us v. So when we differentiate the first equation for the position with respect to t, it's going to give us velocity. Then when we differentiate with respect to t, the formula for v, it is going to give us the acceleration. This is just how calculus works. So if you don't know calculus, if you've not covered calculus, don't worry, just master the final equation and then you can use it. And then also I'm going to give you another simple method that can simplify things for you. So now we have our x being equal to 3.0 meters cos over 6, or in parentheses. So now we are being told to differentiate this x with respect to the t that's inside. So dx over dt of d over dt of the whole of this 3.00 meters cos pi over 6 box parentheses. So now to differentiate this one, let me just move the camera a little bit. So to differentiate this one, we are going to differentiate the angle and then multiply it by everything, and then differentiate this cos. We know that the derivative of cos is the negative of sine. So now we are going to have dx over dt, which is just equal to v, being equal to we have this 3 here, 3.0 meters, which is just a constant. And then we differentiate the angle, we differentiate the trig function is negative sine, and then our angle, we can put this in box parentheses since we are going to use the brackets there. So now our angle, we are going to get the exact same figure, pi t plus pi over 6 in box brackets, and then we differentiate the angle with respect to t. So when we differentiate this one, this is just a constant, and then this is also a constant, and then this is a variable. So when differentiating this one will be 0. You know the derivative of a constant. This one is just any number like 6. When you're told to differentiate 6, it's just a 0. And then this one, we have a variable t. And then when we differentiate with respect to t, since t is to the power 1, we are just going to have pi. This is like it's just like they're telling you to differentiate maybe 2x with respect to x. So we have 2, which is a constant, and then this one, which is a variable. So we are just going to have pi. So when we multiply pi by this, we are going to get the velocity being equal to 3.0 meters. All of this will be multiplied by pi, and then the sine of pi t over 6, and then we are having a negative there, so we are going to put it there. We are going to respect the sign. So now again we differentiate this equation, and it's going to give us the equation for the acceleration. So this is the equation for the velocity, and then when we get any time t and we plug it there, it's going to give us the velocity at that time t. So now we go to the acceleration. So we are saying dv over dt is equal to the acceleration, which is equal to the d over dt of the whole of this, which is negative 3.0 meters. We have pi sine plus pi over 6. This one, we are going to have this is a constant to be left like that, the negative 3.0 meters, and also the pi. This is a unit, it's not a variable, and also the pi. And then we're going to differentiate the trig function. So the derivative of sine is the positive cosine, and then we are going to get what's in the angle as it is, plus pi over 6, and then we are going to differentiate what's inside. So we found the derivative of what's inside there, then we're going to multiply it by everything. The derivative there is pi. So now multiplying pi by all this, we already have a pi there, so it's going to be negative 3.0 meters pi. It's now squared, and we have a cos of pi t plus pi over 6. So now this is our symbolic answer for the acceleration. So then when you plug in t, anytime t, it's going to give us the acceleration at that time t. So then definitely here you know that you've completed the b part of the question, and thus you can find the c, which is telling you to use the b to find it. So now if you're not familiar with calculus, just remember this. We have x being equal to x naught cos wt. We can put the first difference, yeah, like that. So when you're told to differentiate this one, you're going to find the velocity, and then it's going to be the angular velocity. The angular velocity, that will be the derivative of what's inside. So you're just going to get x naught w, the cos, the sine rather, the sine, and then the sine will be negative, so we push the negative there, wt plus the first difference. And then when you're told to differentiate this one, you're going to get the acceleration, and then it's still negative because the derivative of sine is the positive cosine x naught, and then you're going to multiply the wt again, so it's going to be squared cos wt plus the first difference. So now this one, this is how this is coming into play. So you just have to know this. When you know this, whatever equation you're given, you're going to manage to work it out and find everything like that. So that's all for our part B. We can go to part C. So part C is telling us to use what we found there to determine the velocity and the acceleration at a time t is equal to 2 seconds. So at t is equal to 2.00 seconds, we are going to plug in t, and then it's going to give us our velocity and also our acceleration. So there we have v being equal to -3.0 meters. We have our pi, have our sine over there, and then we have 2 where there is, here we put 2 pi, our pi there, plus pi over 6. So now we solve for this equation, and then since everything here is all the things here are constants and we don't have variables, we can definitely find our velocity. So now we can plug it in there. So now we have to simplify our angle there. So we have 3.0. Our angle here, we have 2 pi. So we have 2 pi plus pi over 6. This one is over 1. We have our common denominator 6. 1 into 6 is just 6. 6 times 2, it's 12 pi plus. There we're having just pi. Since 6 into 6 is just 1, so we're going to have pi. 12 plus pi is going to be 13 pi over 6. And so this is our angle that's in there, 13 pi over 6. And thus we can now get 13 times shift pi divided by 6. So that's what's in our angle, and then we get sine of the answer. Then we multiply it by pi, and then again multiply it by 3. It's going to give us 4.7. So we're going to have our velocity to be negative 4.7. The negative that's there, we just drop it down, 4.7. And then since in the question all the values that were being given are correct to 2 decimal places, so we can respect that and put it to 2 decimal places, and we know velocity is in meters per second. And then we get for the acceleration now. So the acceleration is equal to negative this squared, and then we have our cos, and then our angle. And then since the seconds are still being 2 here, so we can just write the 13 pi over 6, since we know that even if we start with this, we are going to go all the way back up to that. So we are going to have our acceleration being equal to times pi squared, the cos 13 pi divided by 6. 5.64 meters per second squared. At D, we are being told to find the maximum speed and the maximum acceleration of the object. Now, first of all, you just have to understand these 2 equations. Where are they? You have to understand these 2 equations, and also you have to understand the sine and the cosine function. Now, the sine and the cosine function have a range of -1 to 1. So whatever you plug in, it can be sine 1000, it can be sine 0.2, it can be anything, but always when you plug in that sign, it's going to give us an answer from -1 to 1. So the most answer you can expect from any sign is 1 or -1. So now, since we're being told to find the maximum, so you know that we have to have 1 in the whole of this. it has to give us 1. The whole of this, it has to give us 1 for us to find the maximum acceleration and the maximum velocity. And also when you come to the maximum displacement, although it's not in the question, all this has to be 1. And that's how this is the maximum displacement, which is the amplitude. So you can understand it coming from this perspective and then going all the way down. So now we can write our equation for velocity, which is v is equal to -3 0 meters. We have our pi, and then our sin t, sin pi t, and everything here, it just has to be 1. And so this is our velocity. We have to multiply this times that. So we have our 3 point pi. So we are going to have 9.4 per second, and then this per second is coming from the angular velocity, because this from the angular frequency, because this is just rads per second. And then so that's for the velocity. For the maximum acceleration, I'll give you 2 ways to find it. You can use the traditional way, or you can just say, you can just multiply this one by pi. Since pi is the angular frequency, pi here is the angular frequency that we found in here, you can just multiply it times the velocity times the maximum velocity, and you get the maximum acceleration, because the only difference between these two, when this is 1, will be pi. So when you multiply it by pi, you're going to get 29.6. So what we're going to do is use the other way of equating this to 1, and thus we are going to have our acceleration being equal to -3.00 pi squared, and then all this will be 1. So our acceleration will be 3 times pi squared. So again, we get the 29.6 that we got earlier. So these are the 2 ways of finding it, and as usual, 2 decimal places, meters per second squared. So that's all for this question. If you have any other questions, you can WhatsApp them to 0978957975. You can please remember to subscribe to this YouTube channel.